Morning to all. Today we have discussed about types of system in thermodynamics. First one, closed loop system and open loop system, then isolated system. The problem for closed loop system. So first of all, 1.5 kg of certain gas of pressure of 8 bar and 20 degrees Celsius occupies a volume of 0.15 meter cube. It's expanded adiabatically to a pressure of 0.9 bar and volume and 0.73 meter cube, and determine the work done during the process, then gas constant and ratio of the specific heat and what values of the specific heats and changing internal energy and finally changing enthalpy. These are the questions, and given data m equal to mass of 1.5 kg, then P1 in initial pressure P1 equal to 8 bar conductor 800 kN per meter cube, then initial volume is 0.15 meter cube and initial temperature 20 degrees Celsius is converted to Kelvin 293, then final pressure P2 after expansible adiabatically. After expansible P2, the final pressure 0.9 bar and equal to 90 kN per meter cube. Then finally, final volume P2 equal to 0.973 meter cube. These are the given data. And find what is the final? And work done W equal to work done, and find out the second one. The R equal to gas constant. Then next one Cp by Cv, then specific volume ratios, and Cp constant pressure and Cv constant volume. Then del U changing enthalpy. Solution. First of all, we need a gas constant R. We know that the gas constant formula P1 V1 is equal to mRT. So P1 equal to mRT. We need R equal to P1 V1 divided by m T1. So we know the data from given and here I get the formulas. The result R is equal to 0.273 kJ per kg. The first and second one, we need a Cp by Cv equal to lambda. Cp by Cv and specific heat ratio. Specific heat ratio of the specific heats Cp and Cv. The lambda is the log P2 by P1 divided by log P2 by P1 by P2. The values are given, and lambda equals to 1.38. Then finally Cp minus and ratio equal to 1.38 Cv and Cp minus Cv equal to R. Therefore 1.38 Cv minus Cv equal to R. So 0.38 Cv equal to 0.273. So Cv is equal to 0.273 divided by 0.38. Then Cv is equal to 0.718 kilojoule per kg. And finally, to get the Cp value, Cp equal to 1.38 Cv. Already I got the Cv value and put it the Cv, and Cp equal to 1.38 into 0.718 equal to Cp equal to 0.99 kilojoule per kg. Then we put it by using of between T and P, temperature and volume relation between needed T2, the final temperature we need. So T2 divided by T1 equal to V1 by V2 power lambda minus 1. This is the formula for T and V, temperature and volume difference. So we need T2 final temperature. Let's say the formula V1 by V2 and power lambda minus 1 into T minus 1. So T2 equal to 0.15 divided by 0.73. Put the value to the T2 and final value of the T2 temperature, final temperature equal to 160.59 Kelvin. So these are next one, change internal energy. The formula we know that del U equal to mCv T2 minus T1. Then del U equal to m equal to 1.5. I think we know that for given data, and into Cv we need to find out, and T2 we find out minus T1 given data, and del U equal to minus
minus 142.5 kilojoule. This is the del U, change in internal energy. Then we got it, we find out del H and change in enthalpy. We know the formula for del H equal to mCp T2 minus D1 and mCp, m equal to mass, Cp and plus constant pressure and T2 final temperature and minus T1 and initial temperature. And put it the data in the formulas. I get a del H equal to changing enthalpy equal to minus 196.6 kilojoule. The final one, the work done equal to P1 minus P2 divided by lambda minus 1. This is the formula, you know that. And put it the data from given. I get a W work done equal to 142.89 kilojoule. This is the final result. Then we know that del U and work done, these are the same, and the negative values for the del U internal energy will be negative value, and the same value for the work done is a positive value. These are the results. So final results. List out the results. Capital R, gas constant equal to 0.273 kJ per kg, and Cp by Cv ratio 1.38. Then Cp equal to 0.99 kJ per kg, and Cv 0.718 kg per kg, and del U internal energy equal to minus 142.5 kilojoule. Then internal enthalpy and minus 196.6 kilojoule. Then final one work done equal to 142.5 kilojoule. These are. Thank you one and all. We see that next video soon.